Have you ever wondered how mountains, these majestic giants, came to be? Each peak, each ridge, each valley has a tale to tell, an epic born of the very fabric of our planet. Mountains are not just static fixtures on our landscape, but dynamic entities sculpted by the ceaseless drama of geological forces. This drama, as old as the Earth itself, is both violent and beautiful, a testament to the awesome power of nature. These towering giants, these magnificent mountains, are the result of an intricate dance of geological processes. Born from the fiery heart of our planet, they rise, shaped and molded by forces beneath and beyond our sight. They stand as silent witnesses to the eons of time, each telling a unique story of birth, growth, and transformation. But how does this happen? How does a planet of molten rock and swirling gases give rise to these towering peaks and expansive ranges? The answer lies deep beneath the surface, in the hidden mechanisms of our planet. The birth of a mountain is a tale of fire and stone, of pressure and time. It is a process that begins deep within the Earth's crust, where tectonic plates, vast slabs of rock that make up the Earth's surface, interact. These interactions, fueled by the heat and pressure from the Earth's core, set the stage for the birth of mountains. This is not a quick process. It is a geological drama that unfolds over millions, even billions of years. It is a story of slow, persistent change, of the relentless forces of nature that shape and mold our world. It is a journey that takes us from the deepest depths of the Earth to the highest peaks of our planet. So how do these processes work? How do they give rise to the majestic peaks that dominate our landscape? The answers to these questions are as fascinating as they are complex, and they are the story we will explore in this video. Join us as we unravel the geological drama that has shaped Earth's awe-inspiring mountain ranges. From the fiery birth of a mountain to its gradual shaping and transformation, this is a journey into the heart of our planet, a journey into the birth of giants. Imagine the Earth's crust as a massive jigsaw puzzle, constantly moving and interacting. That's a pretty fitting description when we dive into the world of plate tectonics, a fundamental concept to understanding the formation of mountains. Our planet is covered in a patchwork of massive, rigid plates, each one carrying a piece of Earth's crust. These plates aren't static, but rather they're always on the move, albeit at a pace slower than the growth of our fingernails. However, it's this slow and steady movement that sets the stage for some of the most dramatic geological phenomena, including the formation of mountains. Let's break down this geological drama into three key acts: subduction, collision, and continental uplift. Each of these acts plays a crucial role in the creation of mountain ranges. Subduction is the process where one tectonic plate is forced under another. This usually happens when a denser oceanic plate meets a less dense continental plate. The oceanic plate, being heavier, sinks into the mantle beneath the lighter continental plate. This doesn't happen without a fight, though. The descending plate drags against the overriding plate, creating intense pressure and heat. This heat causes the crust to melt and rise, which can result in the formation of volcanic mountain ranges. The Andes in South America is a prime example of mountains formed through this process. Next, we have collision. This happens when two plates of similar density converge. Neither plate is dense enough to sink into the mantle, so what happens? They collide head-on, and the material caught in the middle is forced upwards, creating a mountain range. The mighty Himalayas, home to the world's highest peaks, are a product of the collision between the Indian plate and the Eurasian plate. The third act in our mountain-building drama is continental uplift. Over millions of years, erosion wears down mountains, and rivers carry sediment to the sea. This can lighten the load on the continental crust, causing it to rise or uplift. The sediment deposited in the sea can also cause the oceanic crust to sink, further driving the uplift of the continent. This process, over time, can lead to the formation of mountain ranges. This geological drama unfolds over millions and millions of years. It's a slow, almost imperceptible process, yet it results in the spectacular mountain ranges we see today. From the towering peaks of the Himalayas to the rugged ranges of the Rockies, each mountain tells a story of the immense geological forces at play beneath our feet. However, the story doesn't end here. The plates are still moving, and mountains are still forming. As long as these tectonic forces continue to act, new mountains will rise, and existing ones will be reshaped. Each movement, each interaction, adds another piece to the complex jigsaw puzzle that is our planet. The concept of plate tectonics revolutionized our understanding of Earth's geology. It provided us with a framework to explain not only the formation of mountains but also other geological phenomena like earthquakes and volcanic activity. It showed us that our planet is a dynamic, ever-changing entity, constantly reshaping itself in response to the forces acting upon it. So the next time you stand in awe of a majestic mountain range, remember the immense geological drama that unfolded over millions of years to create that breathtaking landscape. Each peak, each ridge, is a testament to the power of plate tectonics, the grand shaper of Earth's surface. The shifting of these massive plates is a fundamental driver of mountain formation. It's a slow, steady, and relentless process, a testament to the power of time and the dynamic nature of our planet. As we continue our journey, we'll delve deeper into the geological processes that shape the Earth, exploring the fiery origins of volcanic mountains and the sculpting power of erosion and weathering. Stay tuned as we continue to unravel the geological drama behind Earth's majestic peaks. Moving from the deep tectonic movements, we turn to the fiery depths of Earth's core. As we dive deeper into the heart of our planet, we come face to face with the scorching molten magma that bubbles beneath the surface. This isn't just a fiery spectacle, it's a fundamental part of the geological drama that shapes our world, specifically our mountains. Now, you might wonder, what does this fiery underworld have to do with the towering peaks we see on the surface? The answer, quite simply, is everything. The heat and pressure from the Earth's core create a sort of geological pressure cooker. When the pressure becomes too great, the Earth's crust cracks and magma pushes its way to the surface, forming a volcano. Over time, repeated eruptions cause layers of lava and ash to build upon one another, gradually creating a mountain. Take, for instance, the iconic Mount Fuji in Japan, a stratovolcano formed over hundreds of thousands of years through repeated eruptions. Or consider the majestic Mount Kilimanjaro in Tanzania, the highest mountain in Africa, which is actually a dormant volcano. These are but a few examples of how the fiery belly of our planet has played a monumental role in sculpting some of the most iconic peaks on Earth's surface. But it's not just the magma that's important in the creation of these volcanic mountains. The gases that escape during an eruption also play a crucial role. You see, when magma rises to the surface, the pressure decreases, allowing dissolved gases to escape. This explosive release of gas is often what drives the eruption, propelling magma, ash, and rock into the air. Over time, this ejected material can accumulate and solidify, contributing to the growth of a volcanic mountain. Now you might be thinking, isn't this process incredibly destructive? And you'd be right. Volcanic eruptions can indeed cause widespread devastation. But it's important to remember that volcanoes also play a vital role in creating and shaping the land we live on. They provide rich, fertile soil for agriculture, create new land, and sculpt the breathtaking mountain landscapes that we admire. Moreover, the study of volcanic mountains provides us with valuable insights into the Earth's inner workings. By studying the composition of volcanic rocks, scientists can glean information about the Earth's mantle, the layer beneath the crust. This helps us understand the processes that drive plate tectonics and mountain building. It's also worth noting that while volcanoes are often associated with destruction, they're also a source of life. Many ecosystems thrive on the nutrient-rich soils that volcanoes produce. In fact, some species have adapted to survive specifically in these environments, contributing to Earth's rich biodiversity. So next time you gaze upon a majestic volcanic peak, remember the fiery drama that led to its creation. Consider the colossal forces at play beneath the Earth's surface, the explosive eruptions that shaped its form, and the countless years it took to sculpt the peak you see today. As we continue our journey through the geological drama that shapes our Earth, let's not forget the role of fire and stone. From the molten magma bubbling beneath the Earth's crust to the towering volcanic peaks that punctuate our landscapes, the interplay of these elements is a testament to the dynamic and ever-changing nature of our planet. Volcanoes are not simply destructive forces but creators, architects of the land. Each eruption, each layer of lava and ash, each escaping gas, contributes a verse to the geological epic of our planet. Volcanic activity, while destructive, is a key player in the creation of some of the world's most iconic mountain ranges. The fiery depths of our Earth, the molten stone, the explosive gases, all come together in a spectacular display of geological might, giving birth to the breathtaking peaks that command our awe and respect. So, as we marvel at the majesty of mountains, Let's remember to pay homage to the fire and stone, the unsung heroes of this fascinating geological drama. Now let's explore how nature's elements play the role of sculptors, continuously shaping and reshaping mountains. If you ever wondered how mountains get their unique shapes, the answer lies in the relentless work of nature's sculptors: erosion and weathering. These processes, powered by wind, water, and ice, etch the character into the face of our planet, transforming the jagged edges of newly formed mountains into the grand peaks we admire today. Imagine for a moment the ceaseless dance of the wind across a mountain's surface. Over thousands of years, the wind, carrying small particles, wears away at the mountains, sculpting them into unique forms. This process, known as wind erosion, has been at work for eons, creating some of the most stunning landscapes on Earth. Now let's turn our attention to water, a powerful sculptor in its own right. From the gentle flow of streams to the mighty rush of rivers, water carves its path through mountains, creating valleys and canyons, and shaping the terrain. Rain too plays a part in this process, gradually washing away loose material on the slopes, a process known as weathering. And then there's ice. In colder climates, the freeze-thaw cycle of water can cause mountains to crack and crumble. Water seeps into the cracks, freezes, and expands, causing the rock to fracture and break apart. Over time, this process, known as frost weathering, reshapes entire mountain ranges. Together, these natural elements, each a sculptor in its own right, continuously mold and shape the mountains. They soften the rough edges, chisel out the valleys, and carve the majestic peaks that inspire awe and wonder in us. So the next time you stand in awe of a mountain's grandeur, remember the relentless work of wind, water, and ice, nature's tireless sculptors. These forces, over countless centuries, have been working to create the breathtaking landscapes we see today. Erosion and weathering over time give mountains their unique and awe-inspiring shapes. Next, we delve into the world of folding and faulting, two key mechanisms in mountain building. These processes are all about the Earth's crust, the rigid outer layer of our planet, which is constantly in motion, shifting and sliding, colliding and separating. As these tectonic plates move, they create immense stress that has to go somewhere, and often, that somewhere is upwards, forming the majestic mountain ranges we see today. Let's start with folding. Picture a tablecloth being slowly pushed together from opposite ends. The material doesn't have anywhere to go but up, forming ripples. Now replace that tablecloth with layers of rock. This is essentially what happens during the process of folding. Over millions of years, tectonic forces compress and bend the Earth's crust into a series of waves, known as folds. These folds can be gentle rolling hills or towering mountain ranges, depending on the extent of the forces at play. The Appalachian Mountains in eastern North America are a classic example of a folded mountain range. These mountains were formed around 300 million years ago when the North American and African plates collided. The immense pressure folded the Earth's crust, creating the ridges and valleys that make up these ancient, worn-down mountains. Now let's turn our attention to faulting. Faults are fractures in the Earth's crust where blocks of rock have moved past each other. This movement can be horizontal, vertical, or a bit of both. When vertical movement occurs, it can lead to the formation of mountains. Imagine breaking a chocolate bar. The pieces don't always break cleanly. Sometimes one piece ends up pushed up above the other. This is similar to what happens during faulting. The immense forces within the Earth's crust cause it to crack, and these cracks or faults allow blocks of rock to move relative to each other. When a block is thrust upwards, it can form a mountain. The Teton Range in Wyoming, United States, provides a dramatic example of fault block mountains. These jagged peaks were formed by a series of earthquakes along a fault line, causing the western block to rise and the eastern block to fall, creating the deep valley known as Jackson Hole. But folding and faulting aren't just about the birth of mountains. They also contribute to the ongoing evolution of these landscapes. Over time, erosion wears down the peaks, while tectonic forces continue to push them up. It's a never-ending cycle, a geological dance of creation and destruction that shapes the world we see today. The immense forces of folding and faulting have given rise to some of the most distinctive mountain ranges on Earth. These mechanisms, while invisible to us in our daily lives, have had a profound impact on our planet, shaping the landscapes that have captivated human imagination for millennia. From the Himalayas to the Rockies, every mountain range tells a unique geological story. These natural titans, standing tall and proud, are the result of millions of years of geological processes, each with their own distinct narrative etched into the very rocks that make up their majestic peaks. Take, for instance, the Himalayas. These towering peaks, which include Mount Everest, the highest point on Earth, are the result of one of the most dramatic geological events in our planet's history. Formed from the collision of the Indian and Eurasian tectonic plates, these mountains are a testament to the immense power of plate tectonics. The sheer force of this collision has resulted in the creation of a range that continues to grow even today, as the Indian plate pushes further into the Eurasian plate. On the other side of the globe, we find the Andes, the longest mountain range in the world. This geological marvel is a product of subduction, formed as the Nazca plate plunges beneath the South American plate. This process fuels the range's volcanic activity, which has created some of the world's highest volcanoes and given birth to a landscape that is both rugged and beautiful. Then there are the Rocky Mountains, a range that stretches across North America. These mountains are the product of a different kind of tectonic activity. Rather than collision or subduction, the Rockies were formed through a process known as uplift. As the Earth's crust was stretched and thinned, large blocks of rock were pushed upwards to form the towering peaks we see today. But mountains are more than just geological phenomena. They're also deeply ingrained in the cultures of the people who live in their shadows. For example, the Himalayas are considered sacred in several religions, including Hinduism and Buddhism, and have been a source of inspiration for countless works of art and literature. Similarly, the Andes have played a significant role in the cultures of South America. The Inca civilization, for instance, held the mountains in high regard and believed them to be the dwelling place of their gods. Today, the Andes continue to influence the lives and cultures of the people who call this region home. The Rockies, too, have had a profound impact on the cultures of North America. For many indigenous tribes, these mountains are sacred places, filled with spiritual significance. Today, they continue to captivate us with their natural beauty, drawing millions of visitors each year. From their geological origins to their cultural significance, mountains are truly awe-inspiring formations that have shaped not only the Earth's surface but also the lives of those who live among them. These majestic ranges stand as testaments to the incredible geological forces at work. As we look toward the future, mountains continue to evolve, shaped by both natural forces and human activities. The story of our planet's peaks is far from over. In fact, it's a tale that's constantly being written. Geological change, albeit slow on a human timescale, is a relentless process. Consider the Himalayas, for instance. These mighty mountains are still growing, with the Indian plate pushing against the Eurasian plate, causing the land to buckle and rise. This tectonic ballet, while unnoticeable in our day-to-day life, is slowly pushing the peaks higher and higher, even today. But it's not just the natural forces that are shaping our mountains. Human-induced climate change is leaving its mark too. As global temperatures rise, glaciers that have sculpted our mountains for millions of years are melting at an unprecedented rate. This not only impacts the aesthetic beauty of these landscapes, but also has far-reaching implications on local ecosystems and water supplies. The thawing permafrost atop mountains is another area of concern. As it thaws, it destabilizes the slopes, increasing the risk of landslides. This not only poses a threat to mountain communities, but also reshapes the mountain landscapes in ways we are yet to fully understand. And then there's the impact of human activities like mining, deforestation, and infrastructure development. These activities, while necessary for our modern lives, can cause significant changes in the mountain landscapes, often leading to soil erosion and habitat loss. Yet, understanding these changes also offers us an opportunity to better manage our activities, to mitigate our impact on these awe-inspiring landscapes. It's a chance to ensure that the majestic peaks continue to inspire future generations, just as they have done for countless generations before us. As stewards of this planet, it's crucial to understand and respect these geological processes. After all, the mountains we admire today are not just static monuments of the past, but dynamic, evolving landscapes, forever shaped by the relentless forces of nature and the actions of humankind. Mountains, these rising giants, are the result of millions of years of geological drama. They are the embodiment of an epic tale of creation and transformation, a testament to the relentless forces of our planet. From the birth of giants in the depths of the Earth's crust, Through the intricate jigsaw puzzle of plate tectonics, to the fiery influence of volcanic activity, mountains bear the mark of these profound processes. The story doesn't end there, though. The ceaseless work of nature's sculptors, wind, water, and ice, continually shape and reshape these towering landforms. Beneath their rugged facades, the drama of folding and faulting plays out, forging the unique landscapes we marvel at today. From the awe-inspiring peaks of the Himalayas to the majestic ranges of the Rockies, each mountain holds its own tale of geological evolution, a testament to the power and beauty of Earth's dynamic processes. Next time you gaze upon a mountain, remember the incredible journey it has taken to reach its majestic height.